Please message Vito, no? So we can start. Again, it's already 7:01. We already discussed this matter that we will always start exactly at 7 p.m. I already gave you 1 hour to prepare for this class, no? So being late is no longer accepted. Okay, so I will just first check the attendance. Talad, Taladhay, okay. Samonte, Zeng, Karag, Wang, Yu, Barhama, and we have Gamboa, Alabado, Santos, Magalona, Reyes, and Chow. Chow. Okay, so 13. Sino may contact kay Guido, please contact him. We can start.
Doc,
Yes,
hello?
go ahead. Yes, go ahead.
Doc, I messaged Sir Ken. He said he sent you a message on Facebook Messenger.
Hmm. Messenger?
Yes po.
Messenger email.
Sabihin niyo Messenger po. Kasi sinabi ko sa kanya
Na,
uh, to start na po sana sa report niya.
oh, where is him?
Ang sabi niya, sorry ma'am, I'm at work. I message him sa Messenger.
So what do you mean at work? He is not attending the class?
Wait lang.
Um, if that's the case, you should inform me earlier. So hindi, we already online class, di ba? Okay, thank you. Okay,
Hi
good evening
everyone.
again. So, yes, I guess so Kenneth is already here. Now, before we start, I would just like to be clear again what is being graded during your presentation. Now, the following are the criteria for reporting. First, reporting, 10 points, how you present your topic. Second is 10 points for the Q&A. Another 10 points for the PowerPoint presentation, the content, and how you present it. And then the last 10 points will be about the content of your report itself. Okay, so you have 40 points during the presentation. Okay, so I guess Guido, you can now prepare your report and let's start in the internal quality control. Thank you very much.
Okay, Doc. Share. Visible to end. So good. So good evening everyone. Good evening, Dr. Francisco. I'm going to report about quality control. Before that, let us define what is
Kenneth,
quality.
i,
As what
sorry,
Edward Deming said,
sorry, Kenneth, i-off mo yung mic or speaker ng isang
yes, Doc.
device mo. Nagpi-feedback eh.
Um, is acting as the
We cannot hear you, Kenneth. Parang inok mo naman yata yung mic na dilaw. Sorry, sorry. Guys, narinig niyo ba?
something reforms.
Okay. Hello? We cannot hear you. Ako lang ba? Guys, ako lang ba hindi nakakarinig? Clear ba sa inyo si Kenneth?
Choppy siya to.
Kenneth, please check your... Parang hindi niya tayo naririnig. Paki-message nga si Kenneth, please.
And the review and work. One is the analytic program by control sample 1,000 tests along with outpatient samples. As mandated by ISO 15189, series of 2012, the laboratory shall design quality control procedures that verify the attainment of the intended quality of results. Control substances that contain an established amount of the substance being tested or the analyte. So the purpose of our control is to validate the reliability of the test system and evaluate the operator's performance and environmental conditions that might impact results. Now, quality is important in the sense that it can aid. Quality control is important in the sense that it can aid in detection, evaluation, and correction of errors that may be due to test system failure, environmental conditions, or operator performance before patient results are reported. Moreover, measuring QC samples aid in evaluating the measurement process to confirm that the method employed continues to perform within the acceptable limits. Thus, quality control gives the laboratory the accurate and reliable. As mentioned previously, there are two types of control: internal quality control and external quality control. Internal quality control survey the precision and accuracy of methodologies, personnel, and instruments daily. Essentially, quality control aids in identifying issues that arise routine operation laboratory methods caused by the instability of the methods. However, there are several problems encountered during catalyzing an internal quality control, such as first is quality of control materials, second, the types and frequency of possible errors, third, the number and types of control materials, fourth, the number of replicates of the control, fifth, probability of error detection, sixth, probability of false rejection, sorry, 7. Consequences of reject signal. 8. Troubleshooting system. 9. Prevention of errors. Now, in a study conducted by Chen et al. Entitled Failure of Internal Quality Control in Detecting Significant Reagent Lot Shift in Serum Creatinine in Measurement for patient specimens using different lots of reagents. The comparison between lots was performed. The result in the study is that although internal quality control was consistent, serum creatinine concentrations were higher using lot B than using lot A. The mean percentage difference between these two lots was 34%. In the study, it is concluded that the difference between in creatinine concentration proved to be due to the different lots of reagents. Now, what is external quality control? External quality control maintains long-term accuracy because it validates the performance of the laboratory. This compares the results from other methods in other laboratories, and and external quality control has several benefits, such as it serves as an early warning system, it identifies training needs, provides objective evidence of laboratory quality. I will go to some, or we will review some basic concepts. Now, here is the um, a normal Gaussian distribution curve. So in a perfect setting, the data collected from assaying quality control samples, at least 20 samples over 20 to 30-day period, and this will have to yield the same value over repeated measurements. However, there is a degree of variation that may be due to operator technique, environmental condition, or performance characteristics. A normal distribution is also known as Gaussian distribution is the resulting pattern when several measurements are taken and the value of these measurements are assayed. So we measured so what so basically we are measuring for the accuracy, which is the closeness of a measurement to its true value, precision, the amount of variation, bias, this is validation of test result and an accepted reference method. And this might be new, but quality goal index ratio, this represents the relative extent to which both bias and precision meet the respective quality goals. Now, the center or the center of the curve is measured. These are the mean, which is the most commonly used, often called average. Second is the median, which is the middle point that is often used with skewed data. And the third one is mode, which is rarely used as a measure of data center, but is more often used to describe data that seems to have two centers. So in calculating for the mean, all the points of the data are summed up and divided by the number of the data. So in order to measure the spread of the curve, so this range is the largest value in the data minus the smallest value. Then the measure of spread is the most frequently used measure of variation is the standard deviation. Coefficient of variation allows a laboratories to compare SDs with different units and reflects SDs in percentage. This is used to monitor precision. And the standard deviation index is a calculation to show that the number of SDs a value is from the target mean. Now, these are the formula for mathematical coefficient of for coefficient of variation. So as you can see, CV is equals to, so the standard of deviation is divided by the mean multiplied by 100. Then deviation, and the last is for the mathematical formula for standard deviation index, by which the laboratory mean is subtracted by the group divided by the group SD. So lastly, the shape is also measured. Shape is often called a bell curve, and shape is defined by how distribution of data relates to the center. So this is a normal curve. So as so 60% of the data fall between -1 and +1 SD. 95.4% of the data falls between -2 and 2 +2 SD, and 99.7% of the data falls at -3 to +3 SD. So so how about if when two different methods are compared? So these are called comparison of methods of experiments, and this involves measuring the patient specimens by both an existing reference method and a new reference method, at least in these experiments. So this is a simple linear regression. So how to process QC programs? So first, these are the stages of a QC program. First is to establish or verify allowable statistical limits of variations for each analytical method. Second is to use these limits as criteria for evaluating the QC data generated for each test. Third is to take action to remedy errors real time when indicated, such as finding the causes of error, taking corrective action, reanalyzing control and patient data. Now, before establishing or verifying allowable statistical limits, it is necessary to select a necessary for adequate statistically QC. QC material should be selected to provide analyte concentrations that monitor the analytic measurement range of the method. The QC sample selected must be manufactured to provide a stable material that can be used for an extended period of time, preferably 1 or 2 years. or more. However, there are limitations for QC materials, such as that QC material is frequently non-commutable with clinical patient samples, and there is possibly like being storage. Now let so so remember this is on our first step for QC program. This establishing quality control target value and standard deviation. So the QC target values and acceptable performance limits are established to optimize the probability to detect a measurement defect. A QC material must have a reliable target value that represents the condition when systematic bias is as small as possible. So the generally accepted protocol for target value assignment is to use the mean value for measuring a QC material a minimum of 10 times on 10 different days. Some QC materials are provided with pre-assigned target values and ranges intended to confirm that the measurement procedure meets the manufacturer's specifications. In addition to target value, an SD is estimated for a QC material that represents the expected imprecision of the measurement procedure when it is performing according to design specifications. So a minimum of 20 observations is recommended for an initial estimate of standard deviation. It is important to include all valid QC results in the calculation of SD to ensure that the SD correctly represents expected measurement procedure variability. When a method has been established in a laboratory and a new lot of QC material is being installed, the target value for the new lot of QC material is used along with the well-established SD from the previous lot. Um, aside from this, the measurement of performance is measured. So this through the use of a sigma metric. So this assess how well a measurement procedure performs relative to the performed. The sigma scale compares the variability of measurement process and standards, and the sigma metrics is calculated as sigma. So the TEA is the analytical objective and minus or subtracted by the bias and divided by the coefficient of variation, which are the indicators of systematic and random errors. So in a study conducted by Kuman and Mohan entitled Sigma Metrics as a Tool for Evaluating the Performance of the Internal Quality Control in a Clinical Chemistry Laboratory, it was shown that Sigma Metrics is a good quality tool to assess the analytical performance of a clinical chemistry laboratory. So the purpose of their study was to evaluate the performance of individual analyte tests on the sigma scale by calculating the sigma metrics for individual parameters and to follow the Westgard guidelines for appropriate Westgard rules and levels of IQC that requires to be processed. The data required for the study were collected from July 2015 to June 2016 in a government hospital in India. And the data obtained for the study are internal quality control values, coefficient of variation, and equals minus bias percentage for 16 analytes. So the result of this study, they have found some of the values to have through sigma metrics that there are some analytes that has a imprecision, two have none, but notably cholesterol is inaccurate. So the researchers concluded that sigma metric analysis provides a benchmark for the laboratory to design a protocol for IQC, address poor assay performance, and assess the efficiency of existing laboratory process. So the next stage for QC plan or development is graphing. So the control ranges are graphically represented for the purpose of daily monitoring, and this is the example of how to plot a Levy-Jennings chart. So I have here 31 data of a calcium result of a quality control. So the mean for this is 2. Variation is 100.13 and the coefficient of variation is 2.9. So this is the result of the um, the data. So this is the Levy-Jennings chart. So the mean for this is 100.1. We have here the SD, which is the 102.73. 2SD plus 2SD 105.7 and 94.5, and 3SD with 85 and 91.7. So as shown here on the data, there is no in the data that has passed, or there is no um, there's no rejection or errors in the data, meaning that there is no any random or systematic errors. So anyway, to establish interpreting IQ results, the Westgard multi-rule systems is applied. So 1-2S refers to one control observation which exceeds the 1-3S refers to control is rejected, same control measurement exceeds the mean of plus minus 3 SD limits. 2-2S refers to the control where rejected control exceeds the same mean plus minus 2 SD. So R4S refers to a control rule where a run is rejected when one control measurement in the group exceeds the mean plus 2 SD limit and another exceeds the mean minus 2 SD limit. 41S refer to the control rule where 4 consecutive control observations exceeding plus 1S or minus 1 SD. And 10X is a rule where R run is rejected when 10 consecutive measurements fall on one side with the mean. So I have here an example. So the rule that is violated here is 1-2S because one data here falls on above the 2SD. So another one here is another rule that is violated is R4S because here is about plus 2SD, while the preceding or the consecutive one is located below the minus 2SD. Lastly, here is a data for 10x. As you can see here, 10 data points falls on one side of the mean. So anyway, the error, so two errors or types of errors. These are the random error in which the test run exceeds 2SD. So however, this means that no failure in the analytic run. Then another one is systematic error. This is unacceptable. This indicates failure during the analytic run and it needs to be corrected. So there are two types of systematic error. First is the change. The control falls on one side of the mean for 5 consecutive runs. While trends, this is a gradual change. The control value. So when do we measure quality control samples? So there are criteria when to measure a quality control samples. First is the analytic stability of the measurement procedure. So the assay controls at least, or the assay controls must be tested at least once per 24 hours or more frequently. Second is the risk of harm to a patient frequent to avoid the situation of discovering a methodologic problem. So it is recommended to do more frequent QC measurements so that it will negate some situations when a methodologic problem was discovered later in time. So next is a number of patient results produced in a period of time for the scheduled events. So for continuous measurement processes, QC samples, or it is recommended that QC samples must be measured before scheduled events such as recalibration and events to verify measurement procedure performance. And the next is training and competency of the test operator and the risk of failure of device. So what are the corrective actions to be taken? So these are the steps when correcting an error. So first is to assay and import of clinical samples must be stopped. So if if an error detected, assaying and reporting cleaning samples must be halted. Next is to repeat quality control measurement. Third is to measure a new container of control. Fourth is identify and correct the measurement error. Is to repeat controls and do further technical investigations. So first is probably there is deterioration of reagents or kits. Maybe there is degradation of the control material. Next, maybe there is an error from the operator or is able to follow instructions from the manufacturer. Plus, there's an outdated procedure manual, probably an equipment failure or calibrator error. And lastly, an inadequate sample volume has been tested. So here's a chart if there is or a pattern. So after repeating the QC measurement, is the value on the repeat measurement acceptable? If it is acceptable, testing of patient can resume. However, if it is unacceptable, there might be possible deterioration of QC materials. The measurement might be taken on the new vial or control material, or using a new vial or control material. However, if However, after repeat measurement on a new vial or container of the QC material, if the QC is the testing can resume. However, if no measurement problem exists and there must be a need to investigate. Problem. So is the QC result acceptable? Yes, testing of patient can resume. However, if still down, no, instrument and reagent should be inspected and instrument or the analyte must be recalibrated. So lastly, so instrument and reagents instrument and reagents is the problem identified and corrected? Yes, the QC sample should be measured and return all clinical samples since the time of the QC, so since the time of the previous QC results. However, if the problem is not identified and corrected, this is the time to do further technical investigation. So lastly, so reviewing quality control data, QC data must be reviewed by laboratory management on a regular schedule. So during the weekly basis, this is to determine the correct follow-up. During this time, this is to determine the correct follow-up of any QC alerts was conducted, examination of the Libby Jennings chart or other tool to identify trends or changes in assay performance. On a monthly basis, any issues identified by the weekly review process must be identified. Consistency of reagent lot changes, calibrator lot changes, and any patient database QC procedures. So during QC reviews, or the purpose of QC review is that it verifies the stability of test procedures and performances specifications are met. Second is to single out test procedures that requires intervention to address trends. Next is some I guess people do this delta check. So this is to compare a patient's current. This is most useful to detect misstable samples and samples altered by dilution intravenous fluid during collection of a patient. This can detect analytical errors, but threshold values necessary to identify analytic errors will be fairly small compared with physiologic changes and may cause a large number of false alerts that So we'll move on with a novel trend of quality control. Just a second. Okay, so This is the Individualized Quality Control Plan, or IQCP, which was introduced by CMS, or Center of Medicare and Medicaid system, in 2013. So this is an integration of quality control plan with quality assurance and risk assessment, and it is customized to every or individual laboratory. So an IQCP is not needed if at least two levels of external QC for a non-wave test is performed each day of patient testing. Therefore, IQCP is voluntary. Now, these are the elements of IQCP. This is the first is quality control, second is assessment, third is risk assessment. So, a quality control plan is a written document that describes the practices and procedures performed by a laboratory to reduce the chance of possible failures and errors in test processes. So, this ensures accurate and reliable test results. Proficiency. This includes proficiency testing, maintenance, and trainings are also components of our quality control plan. So, a quality control plan must include the number and type and frequency of testing and criteria for acceptable results of the quality controls. So this must be reviewed, signed, and dated by the laboratory director before commencing of patient testing. So this is an example of quality control plan. First, here is the type of control, the frequency, and criteria for acceptability. So example, two levels of external quality controls from the manufacturer. So the frequency of testing is that whenever a new lot or shipment of reagent, or when there is a new lot and shipment of reagent, every 31 days, there must be a monthly supervisory review. So what are the criteria for acceptability? It must be within the defined QC limits set by the manufacturer. Second is the monitoring of reagent storage areas. So when or how frequent must be done, daily, monthly, and there must be a monthly supervisory review. So what are the criteria for storages must be within 2 to 8 degrees Celsius. While there are some reagents actually that must be stored at negative 20 degrees Celsius or more than negative 20 degrees Celsius. So another component or element of IQCP is risk assessment. So this identifies, evaluates potential failures and sources of errors in the testing process. And this must include evaluation of specimen, test system, reagent environment, and testing personnel. So, for example, what are the potential errors here on specimen? So, probably during patient preparation, specimen collection, or specimen labeling. In test system, there might be inadequate sampling, result reporting, pipettes, or pipetors. In reagent, probably there is a potential error in sources of error in storage condition requirements, preparation, or expiration date. In environment, temperature, light intensity, and humidity might affect the testing system. And lastly, testing personnel, which includes training. So, is the personnel have a proper training? So, in order to do risk assessment, first, um, the laboratory must do risk estimation. So, this evaluates the likelihood or probability of harm for each failure and severity of harm to a patient for each failure. So, the ISO 14971 provides semi-quantitative approach to estimate the probability of a failure rate. So, for probability of failure rate, whenever it is frequent, it's frequent. So probably the estimate is that there's an error once per week. Probable, which 1 month or every. There's improbable probability of error when or failure rate when there is an error once in the life of the measuring system. Quantitative to less negligence if it causes inconvenience or temporary discomfort. Minor if it causes temporary injury or impairment that does not require medical help. Serious if it causes injury or impairment and requires medical health patient if there is permanent impairment or limiting injury, and catastrophic, it causes patient death. So this is an example or a table of risk acceptability matrix. So from up here are the severity of harm, while here in horizontal lines harm. Element of IQCP is quality assessment. So this is the process of monitoring effectiveness of QCP reviews, PT performance, and complaints. So these are the documents needed in order to distinguish and choose quality monitors for quality assessment. So these are quality control records, proficiency testing records, patient results review, specimen rejection logs, turnaround time reports, records of preventive measures, corrective actions and follow-up, and first reports. Another novel method quality control is the Lean Six Sigma methodology. So the Lean Six Sigma methodology seeks to improve the performance of a process by identifying and eliminating causes of defects and errors, resulting in eliminating variation in the process. Ergo, it helps to reduce error and waste. So these are my references for my report. So thank you for listening.
Okay, so thank you, Kenneth, for your presentation. Now, this after the presentation of the reporters, we will have an asynchronous activity. Okay, I will give you some things to answer, and then you will submit it. Uh, Please use the same link that is present in your TLC. Right? Remember in your TLC, I posted a link there for your report, right? So you can submit your asynchronous activity today on the same link, okay, in your TLC. Um, is it clear, guys? You know that link that I posted for your reports, right? So you use that for the asynchronous activity. Okay, so for the report number one, please take note, write this. So what you need to answer is the following. So report number one, you need in one paper or one sheet of paper for your report. So number one is that differentiate um, standard standard from control sira. Okay. Number one, differentiate standard from control sira. Number two is that um, you make a flow chart, okay, a simple flow chart on basic steps in performing uh, internal internal quality control QC. Okay, so again, you make a flow chart of the basic steps in performing internal quality control in chemistry. So in short, you just present it uh, on your own, no? Much more simple, much better. It's like a step-by-step procedure, what to do, no? For example, early in the morning, you are 6 o'clock duty in clinical chem section. What you need to do as part of the internal quality control. Step 1, step 2, step 3, and so on. So bullet type, okay, answer that number 2. And then number 3 is based on the report of Mr. Kenneth, enumerate all the different mathematical equation, okay, and then so enumerate that and then state their importance, or application. Okay, so for example, yung bell curve, which is very basic, no? So what is the use of this bell curve in quality control. So what information we can get from bell curve, what information we can get from Sigma internal quality control. So that is number three. Any question? Did you get the content of report one? Okay, so in one, okay, so Peter Samonte typed it. Number one, differentiate standard from quality control SIRA. Number two, make a flowchart on the step-by-step performance of the internal quality control. Number three, based on the report of Mr. Guido, enumerate all the different mathematical equation or mathematical formula that can be used for quality control purposes, state their importance or application. Okay, thank you, Mr. Samonte, for that. Okay, so we're done with the first part.